Hi everyone, welcome to my channel, Tutorlini Test Prep. Today we'll be going over 7 hard problems for the November 2023 DSAT. Problem Sette number 3. The goal of the Problem Sette series is to provide an original worksheet of challenging problems right before the test date. This gives students the opportunity to push themselves while also reviewing a variety of topics. Please download the worksheet for free using the link in the description and attempt the problems yourself before watching this video. Let's get started. Okay, everybody, so the equation that they're testing us on for this one is y equals a times b to the t over n. It's an exponential function where we have to account for time. So let's just first kind of talk about this briefly, then we can tackle the question. So a is your initial value. B is your multiplier. When we're talking exponentials, we call that a growth or decay factor. T is just time, so that's just your x. Nothing crazy there. But there's this new letter that you really need to make sure you understand. N, which is the interval. The interval tells you how often that growth rate B or decay rate B is fully applied. So another thing people tend to forget is that the interval, I'll just write N. N has the same units as T. So let's use this equation and kind of look at this question. So I see 2,400 and I'm going to go, okay, so we're starting with $2,400. That's our initial value. This part here, they don't ask us about this, but this should ring a bell to you. This B, it tells you you're multiplying by 1.75. The way we would phrase that on the exam is we would change that multiplier to a percent. So I'm going to do 100 times the percent multiplier minus 1. I've gone over that a lot in my videos. So this is, I get positive 75. So this is a 75% increase. And I'm wondering how often, and it appears, I'm like, it should be underneath here. Why isn't it underneath there? Well, basically, guys, when your interval is a fraction, when you divide by a fraction, you reciprocate. So we can rewrite this as 2,400, 1.75 to the t over 5/6. Hopefully that kind of makes sense. When you divide by a fraction, that's the same thing as multiplying by the reciprocal. So it is undergoing a 75% increase every 5/6. Let me change it back to blue. And then t is in years. So n has the same units as t, so it's every 5/6 years. Okay, now that we have that written down, we can try to figure out what they're asking us. It wants us to figure out how long it takes to go from 2,400 to 4,200. And you see, guys, we don't even need to, use a logarithm or anything. We can just go, oh, what is 2,400 times 1.75? Oh, 4,200. Okay, so it's basically just asking how long does it take for one growth factor to be applied. It's just a really fancy roundabout way of asking you for the interval. So the answer is 5/6 years, but it says months in the question. So make sure you pay attention to that. Months. So we need to change 5/6 years to months. And to do that, we're going to multiply by 12 because there's 12 months in a year. So the answer is actually 10 for this one, 10 months. So let's go back and jot that down. So please, please, please make sure you understand every little bit of intricacies about this equation I wrote on the board. A is your initial value, B is your multiplier, which often has something to do with percent change, which we talked about in other videos. N is your interval. The interval N has to have the same units as T. So sometimes they ask you to convert the interval. So pay close attention to that. Okay, answer is 10. Let's go on to question 2. Okay, very first thing, guys, if you haven't watched this, definitely go check out my video, Ottocento number 6, on linear systems, how many solutions, because I'm just going to assume you've watched that. Okay. So first I'm going to figure out if I'm going to do this completely by hand, which we'll go over Desmos in a second. I'm going to kind of circle all these constants and try to put it into a proportion. So 5 over negative 40, negative 3 over 24, and 8 over negative 64. And all of those should simplify to negative 1/8, so we can set them so we can see that they're equal. So this means we have A over D equals B over E, which equals to C over F, which I go over in the video. And that means they have infinitely many solutions. So these guys are the same line. So that was the first thing you were supposed to realize, is that they had infinitely many solutions, and you can do that just by setting up a proportion and seeing which of the kind of 3 cases it is. Now what we're going to do is we are going to, since they're the same line, they have infinitely many solutions, so they're the same line. Really all we need to do is use one of the lines to test the points. I don't know, why don't we use the one with the smaller numbers, the top one? I feel like that would be less work if we're doing this completely by hand. So we'll do 5x minus 3y equals 8. And pretty much what College Board wants you to do is basically guess and check each answer choice. So if you want to do that, pause this video right now because I'm going to tell you the answer. Because I'm not going to go through and plug in all of them. Okay, last chance. So the answer to this guy is C. I believe, yep. So what we're going to do is we're going to plug in that x and y coordinate. So 5, 3r over 5 plus 8 over 5 minus 3, and then y is just r equals 8. Okay, I get 3r plus 8 minus 3r equals 8. 3r minus 3r goes away, so I get 8 equals 8. So this one is good. It's true all the time. And that means C is the answer. If you went through and plugged in the other ones, you would not get the same thing on both sides at the end. So it would not be true for every real number R. So the answer is C, but you should be jumping for joy if you see this question on the test, because you can do this question incredibly easily using Desmos. So let's type in 5x minus 3y equals 8 and negative 40x plus 24y equals negative 64. And we kind of see that they perfectly replace each other, so we know they have infinitely many, so we didn't even need to do that. Now we're going to just start typing in the answer choices. So I'm going to do capital A equals negative r over 8 minus 8, comma, r over 8 plus 64. And we'll make a slider for r. How about Okay, and I'm just going to label this A. And I'm going to do B equals 3r over 5 plus 8, comma 3r over 5 minus 64. And we'll label him, make him orange, and we'll call him B. And let's do C equals 3r over 5 plus 8 over 5. Oh, forgot to put parentheses, 1 sec. 3r over 5 plus 8 over 5, comma r. And we'll call him C. And then D equals r, comma 5r over 3 plus 8 over 3. And we'll call him D, and we'll change the color to, how about purple or something. And you see, if it's true for every number r, when I change r, the point should essentially just slide along the line like a ball on a string. So watch what happens as I change r. See how C goes right along the line like a ball on a string, but none of the other ones do that. So that means they're all wrong. A, B, and D are all wrong. And you see, even if I make this like really wide interval, and I zoom out more, you'll see that that just always happens. So just C keeps going perfectly along the line. A, B, and D, they may touch the line sometimes, but not for each real number r. It has to be for every real number r, for any number you can think of. So the only one that seems to do that is C. So this question, if you knew how to type that into Desmos, you were in super business. However, you really got to make sure you understand those concepts about no solution, one solution, infinitely many. Make sure you check out my video, Ottocento 6. Very helpful. All right, let's come back over here. Let's keep going. Unit conversions, I got a video on this too. This is, I think it's the second one. Can't remember. Ottocento number 2. So we're going to write 1.3 square inches per second. I'll just write S for a second. And it seems like we have to do stuff between seconds and hours. There's 60 seconds in a minute. There's 60 minutes in an hour. You got to know both of those. And you should also know that there's 3,600 seconds in an hour. So I would write that down just as soon as I start. Okay, why don't we do the inches first? But before I go to convert, I notice that I want to convert square inches, and this does not have square inches. So I got to do something about that. I went over this in the video. We're going to square the entire unit conversion. So this is 1 squared is just 1 inches squared. And then 0.254, I don't know what that is, but it doesn't matter. I can just put a square in Desmos. Squared, decimeters squared. So that's the actual unit conversion you're going to do. Now we're going to do the factor label method. So we're going to put 1 inches squared on the bottom and 0.254 squared decimeters squared on the top. And you see now, because we did it like that, these square inches cancel. So now we have decimeters squared per second, but we want decimeters squared per hour. So we're going to set up another unit conversion. And we're going to put 3,600 seconds on the top and 1 hour on the bottom. And let's double check. Are they on opposite sides? Yes, they are. So we can cross out the seconds now. And we are now left with decimeters squared per hour, squared decimeters per hour, which is what we want. So now that we have that, we can go to Desmos and type it in exactly as we wrote it. exactly as we wrote it so we don't make a mistake. So 0.254 squared over 1, and then 3600 over 1. Just typing in exactly as I wrote it. No reason to leave it up for error. And we want to round to the nearest tenth, so that would give us 301.9 square decimeters per hour. And that is our answer. Okay, very good. Definitely check out my video on unit conversions if that gave you trouble. All right, let's come back over here. Okay, so this is a triangle proofs question. We don't need all these for this one, but I'm just going to quickly go over all of them kind of off to the side. How about I just do it at the bottom? So triangle congruence, there's 7 rules in total you need to know. And they're not going to give them to you, so you need to have them memorized and you need to understand what they are. So congruence, we got to know SSS, SAS, ASA, and AAS. And for similarity, we have to know SSS similarity, AA, angle, and SAS similarity. I use a little tilde on top to denote that those sides are, pairs of sides are proportional, not equal. So again, I don't want to call it SSS, call them both SSS, and then you think I'm talking about the same one. So it's just a little stylistic thing that I do to make it less confusing, I hope. All right. So as soon as I start, I see this we're trying to prove that it's similar. So the very first thing is I am going to write all these down on my scratch paper before I even start the question. If you didn't remember those, you don't really have a good chance of getting this one right. Okay, now we have to start making the drawing. That's a common theme on the DSAT, is that they force you to make the drawing yourself. I'm going to draw, let me try to make this as big as I reasonably can. 2 kind of similar triangles. PQR seems like the smaller one, so let me put PQR. And then I'm going to put X, Y, Z. The order of the letters is really important. You need to put them in the same kind of relative order of each other, like it talks about up here. Okay, now it says angles R and Z each have a measure of 38 degrees. So let's label that. Then it says that the length of side QR is equal to 11. Let's put that here. And it says the length of YZ is equal to 27.5. Great. Okay, this is looking really good. Okay, now, first, why don't we just check D, no additional information. Looking at our rules, we have a pair of angles and a pair of sides. So that would be like AS. That's not one of our rules, so I feel like there's no way it can be D, not enough information. So we do need additional information. Now we're going to independently, and I'll do this in red, we're going to independently consider each answer choice. So I'm going to write angle P is 46. Does that give me one of the rules? Well, no. Maybe if one of these was also 46, but they didn't tell me about the other angle, so we would get angle, but this one is wrong. Yeah, that's not enough information. We need a pair of information. So let me get rid of this. All right, the length of side PR is 14. And the length of side XZ is 35. Okay, that's actually looking pretty good. This is looking like side, angle, side. This one, SAS. Now we just have to check if it's in the same proportion. So let's do that. So 35 over 14. That gives me 2.5. 27.5 over 11. That also gives me 2.5. Okay, big over small. So it does seem like they're in the same ratio, and it does look exactly like SAS similarity. So this one is looking really good. And I'm actually going to go ahead and lock that in. So let's go back and kind of erase this and then see if we can figure out what's going on with C. Okay, so the measure of angle Q is 49. Okay, so let's put that. And the measure of angle Y is 94. Okay, so you might think like, wait a minute, Kyle, there's no way, right? Those aren't equal. But don't forget to check the third angle. Once you have two of the angles, you can find the third one, right? So let's go back over here. Let me erase this stuff from the previous problem. 180 minus 38 minus 49. Okay, so angle P is 93. And 180 minus 38 minus 94. So angle X is 48. Okay. Let's come back over here. Okay, so it seems like it actually was kind of close. Like, see, 93. If that was just one more different, you know, that could have been AA. Do you see what I'm saying? So, like, don't forget to check that third angle. Maybe there's something going on with that third angle. Anyway, so we didn't get angle, and we don't have another thing of sides. So this one is also wrong. So the only one it can be is answer choice B, which I drew before. Side, angle, side, similarity. So you want to make sure you understand all these, but a lot of you probably do understand these. You just don't remember the rules while you're taking the test. So make sure you know all 7 of these rules by heart, and you write them down on your scratch paper at the beginning of the question. Great. Question 5. This is something I've kind of, glossed over on this channel because it's not that important. But this is a unit circle trigonometry question. And these have definitely been stumping people. So what we're going to do is we're going to do this completely by hand, almost completely by hand. And then we are going to do show you how to do it on a scientific calculator. So let's do it completely by hand first. So guys, I'm going to be honest, a lot of us just don't understand radians well enough to do special right triangles in radians. We just don't. So even though the question doesn't require us, what I suggest you do is, since this could also be on the test, it's a good review, why don't we just convert it from radians to degrees? That's what I tell all my students to do. Like, the numbers will make so much more sense to you if you just convert it to degrees right at the beginning. So the unit conversion, which you should memorize, is pi radians is equal to 180 degrees. So we're going to make a unit conversion. We're going to put pi radians on the bottom and 180 degrees on the top. Okay, radian goes away, pi goes away, and we have 119 over 6 times 180, which gives us 3,570 degrees. And I just used a calculator for just that one part. And, there's one more thing we need to do. Okay, so to be on the unit circle, we want to be between 0 and 360. And recall that 1 revolution is equal to 360 degrees, which is equal to 2 pi radians. So we are obviously not between 0 and 360. So what we're going to do is we're just going to add or subtract 360 until we get a number between 0 and 360 to find the smaller coterminal angle. So let's come over here. So 3,570 minus 360 minus 360 minus 360 minus 360. Just going to keep going. Hopefully they don't give me a number this big on the test. I'm almost there. All right, 330 degrees. So we subtracted because it was bigger. If it was like negative, if it was smaller than 0 to 360, you would add 360. You would add 360 over and over and over again. Great. Okay, so we subtracted 360 over and over and over until we got to a number between 0 and 360. This coterminal angle is 330 degrees. So this angle is coterminal with 330 degrees. Great. Now we can draw a diagram. Okay, so here's 0. I'm going to go counterclockwise. 90, 180, 270. Okay, 330 is going to be like right there. So let's draw that. And we're going to draw a reference triangle with the x-axis. And if this guy is 330, and this whole thing is 360, that means our reference angle, 360 minus 330, is 30 degrees. So this one is 30 degrees, and 90 minus 30 is 60. So this one is 60 degrees. So I can erase that. And now what we're going to do is we're going to, it says unit circle. The radius of the unit circle is 1. So like if this guy is a circle, I'm going to draw a radius of 1. So this radius is 1. And now you might notice this is a special right triangle, something I also made a video on. So let's just, with the magic of television, pull that over here. You don't have to memorize it. It's on the reference sheet. Okay, and now I am going to, the hypotenuse is equal to 2x. The side across from 30 is equal to x, and the side across from 60 is equal to x root 3. So 2x is equal to 1, so that means that x equals 1/2. So this guy is 1/2, and then 1/2 times root 3, or root 3 over 2. And now let's just figure out the coordinates of this point using those two sides. So the x-coordinate is positive root 3 over 2, and the y-coordinate is 1/2, but it's going down into quadrant 4, so it's actually negative 1/2. So that would be the point. And the question asks for the x-coordinate, which is positive root 3 over 2, which is answer choice C. Okay, great. So we'll talk about how to do it on a scientific calculator. I would still just convert it to 3570 at the beginning if you want. You could do radians, but it'll probably make more sense if you do 3570. Now, I think this will work. You can use these equations that you learned in pre-calc. I go over them in the Casio videos a little bit. So x equals r cosine theta. Y equals r sine theta. And theta is equal to tan inverse of y over x. We already were given theta, so I just wrote that because it's related. We're going to use the ones on the left. Great, so let's kind of switch gears here. Let's pull this up. So we're going to do 3570, we said. Let me make sure I'm in degrees. I'm in degrees. You could do it in radians as well, honestly. Why don't we do that just for the sake of, let's see how well this actually helps us. I'm going to switch it to radian. And I'm going to do r, which is just 1. So 1 cosine fraction 119 pi. Oh, I don't know if this is going to work. I think it's going to work. Great, root 3 over 2. Wow, I just did that in 2 seconds. Okay, now let's do r sine theta to get the y coordinate. 1 sine 119 pi over 6. And we get negative 1/2. Great. So you see, if you know those equations at the bottom, and you have a scientific calculator that can do this, these questions become a lot less scary. I mean, they become a heck of a lot less scary, honestly. It's way less work. However, I would still make sure you understand these skills, because you'll get other questions where you have to do those things, like convert from radians to degrees. That could be a different question. Special right triangles, that could be a different question. So yeah, anyway. Great. Okay, let me clear this. Let's come back over here. And I'll make this full screen. Okay, question 6. Top one's a quadratic, the bottom one's a line. This is a linear quadratic system. So a linear quadratic system, once you substitute it, becomes a quadratic. So our plan of attack is we're going to substitute it and use the discriminant. Now, you do not have to always use the discriminant for a question like this. If it's a linear quadratic system and one of the lines is horizontal, you could just try to figure out the vertex and solve the problem that way. But sometimes the line, just like in this problem, is not horizontal, in which case you should probably use the discriminant. I don't know, kill 2 birds with 1 stone. I would just use the discriminant always, because you know it always works. Anyway, okay, so the first thing we're going to do is substitute. So y is by itself on this one, so why don't we put him in over here? So we get 40x minus 4 times parentheses 3x squared minus 5x minus 12 equals a. Okay, so we get 40x minus 12x squared plus 20x plus 48 equals a. And now I'm just going to rearrange this stuff. So negative 12x squared, 40x plus 20x is 60x. And then I get plus 48. And then I'm going to subtract the a over to the other side. Minus a equals 0. Okay, guys, if you don't know what to do from here, please make sure I have a short on discriminant, which kind of goes over how to like pick out A, B, and C and like what the concepts are. I'm just going to kind of assume you've watched that, so I'm not going to go over those notes again. So ABC, AX squared plus BX, and then this whole thing is C, 48 minus A. So let's write that down. A with air quotes, because there's multiple A's, is negative 12. B with air quotes is 60. And C with air quotes is 48 minus A. When you have one real solution, the discriminant tells you that B squared minus 4AC is equal to 0. So you just straight up had to know that. That's just something if you study, that's just something you know. You should just write that down immediately as soon as you see this. One distinct real solution. Okay, hopefully I did all this right and I don't have to redo it. Okay, A is negative 12. Okay, so 60 squared minus 4, negative 12, and then C is 48 minus A equals 0. So what's 60 squared? 3,600. And then minus 4 times negative 12. It's 48. 48 times 48 is 2304, and then minus 48a equals 0. And if you rearrange this, we should get 48a equals 5904. And divide both sides by 48, and we get a equals 123. And that is the correct answer. Great. Desmos could be of some help to you. You could use the slider to try to figure it out. I don't know if I'd do that, but what I would do is I would plot it to make sure I did it right before I moved on. If this were multiple choice, you go, oh, I got one of the answers. I probably did it right. But because it's a student-produced response, you really don't know, right? So there's no reassurance whatsoever. So let's go over to Desmos. Let's refresh this guy. And we're going to type in the original question. 3x squared minus 5x minus 12. And we're going to type in 40x minus 4y equals a. So now, you could kind of figure this out by moving around the slider. You kind of say, oh, somewhere around there, it's going to touch it once, but not very precise. You probably want to do it by hand. Anyway, so the answer we got was 123. And if I zoom in, it doesn't snap to the point. Sometimes they don't do that with tangent lines, or maybe they updated it recently. But if you look very, very close, you'll see that it just grazes that line at one point. So that means it grazes the quadratic at one point. So that means it has one real solution. Great. Okay, let's come back over here. And now we are going to do the last one. This one is not so bad. I really wanted to throw a question about standard deviation in there for you guys because so many people just forget what it is before they test, and I haven't made a video on it yet separately. Anyway, so all you need to understand is that standard deviation is a measure of spread. In other words, it's more specifically, it's how spread out the data is from the mean on average. So if it looks more spread out, you don't need to know how to calculate it. If it looks more spread out, it's got a higher standard deviation. If it's really closely packed together, clumped together, then it has a lower standard deviation. So for this one, I'm looking, and I'm going, man, this one looks really spread out compared to like how packed together this one is. So this one is more spread out. So it has a higher standard deviation, STDEV. So let's see if there's an answer choice that says dataset A is higher. The standard deviation of dataset A is greater than the... Okay, it's the very first one. We're good. That one's A. Now be careful with these guys because they might phrase it the opposite way. They might say dataset B is less. That's still right. It's just it might not be the way you interpreted it in your head. So be very careful with that. So one more thing to say about this. Cannot be determined as long as you know the numbers and you have some kind of picture. You probably can determine it. So I would say that's almost never right. Now, lots of people ask, and this is a great question, Kyle, when is it equal? And they do test you on that sometimes. So it's equal when they spatially look exactly the same. The only difference is that you added or subtracted a number. So I'm going to take dataset B, and I'm going to add 4. So it would look like this: 8, 2 8s, 3 9s, 3 6s, 1 2. So do you see how this data set I just came up with, it is spatially orientated, like 2, 3, 3, 2, all right next to each other. It looks exactly the same as that one on the left. These guys have the same standard deviation. And sometimes they do give you problems like that. Well, they'll give you 2 dot plots. One will look like that, and then the other one will be the same, but like the numbers are like much bigger. 50, 60, 70, 51, 52, 53, 54. So this one has the same standard deviation as this one. So make sure you understand that. More spread out, higher standard deviation. Less spread out, more clumped together, lower standard deviation. Arranged exactly the same, only difference is you added or subtracted a number to all the numbers. Same standard deviation, they're equal. Okay, great. But once a calamity ever so great occurred when 2 holidays met by mistake. Happy Halloween, everybody. I'm not doing a real outro. Best of luck on your exam. I hope this video helped you. Make sure you stop by the community tab and let me know how your exam went. Happy Halloween, everybody. Best of luck.